Hey, we're live. So, hey everyone, welcome to System Seed Weekly Educational Call. Today we're going to talk about Kubernetes, about KOPS, about Helm, how this zoo of technologies work together, and what are the underlying concepts behind this. I'm going to share my screen. I'll show you the whole screen, I think. Let me start. Give me a sec. I'll start streaming. Oops.
You said you will start screaming?
Screaming. But, well, you never know. It depends how the presentation goes. So, Kubernetes, KOPS, and Helm. Let me tell you what is Kubernetes in a few simple words. Kubernetes is also known as Kubernetes or Kube. You might have seen Kubernetes mentioned somewhere. It's the same thing. Kubernetes is an API-based system. It's the system that was designed to make Docker containers reliable and scalable. All of you guys know Docker, obviously. That's not the new tool. But as well as that, you know that if you will drop a container on your local machine or it will be killed by anything, it will never restore until you go and manually just make this container go up again. Obviously, that's a problem for production. The same goes for scalability. You can't scale your Docker container. Just think about the production. You need to be able to provide full reliability and scalability of the infrastructure, which means that you might be willing to run the same Docker container in multiple accessibility zones, on multiple servers, to provide fallback. For example, if one server goes down, your production system is still up. So Kubernetes was designed to solve this problem. And I placed there API-based because all interaction with Kubernetes behind the hood, under the hood, happens through API. And it was designed by Google and developed by Google. Another thing to know about Kubernetes before we dive deeper into that is that it's desired cluster management tool. The desired is a highlighted word here because you can't tell Kubernetes, here's a new state of Kubernetes. No, you actually tell Kubernetes, please, do you mind doing this? And then Kubernetes, if it can, it will do that. So you say, just throw into Kubernetes configs, which describe how you would like your Kubernetes cluster to function. It's not like, you're deploying a code to the application and the application immediately starts working according to the code you deployed. It's different. You can just describe what you want Kubernetes to do. And then Kubernetes tries to do this. So far, so good. Concepts of Kubernetes. I'm not going to talk about everything what is in Kubernetes because you certainly will run out of time, and that's very hard to understand from the first glance, to be honest, to get all of these building blocks. But at least we'll talk about the most commonly used ones. First thing you need to know that Kubernetes has is a node. A node, you can think about this as a server. A node is an instance. It's computing power instance. This can be a server. In case of AWS, this is EC2 instance. Like it can be a virtual server, a physical server. It can be several virtual servers within the same physical machine. It doesn't matter. A node is an instance. There is a cluster. You can hear me talking quite often referring to cluster. And I'm talking about Kubernetes cluster. Kubernetes cluster consists of a master. Master is another node which was just chosen to be the main one. It contains the primary API endpoint. As I said, Kubernetes is API-based system, and it contains many tools that actually do all the heavy lifting. If you think about Kubernetes as an organization, master node is a headquarter of the organization, which holds all the top management, which does the decision-making stuff, and so on. And then the nodes, like workers, or bunch of servers. So, is it clear so far, guys? Maybe you have questions at this point. As I said, let's make this a live talk rather than like me presenting the whole hour.
All clear.
That's cool. Let's slowly move further. So next concept or building block is called pod. It stands for basic unit of deployment in Kubernetes, but I'm pretty sure it doesn't mean anything to you yet. What is like basic unit of what is deployment? Let's talk about this in detail. So you can think of pod as a group of Docker containers or a single Docker container. For example, pod may contain PHP and Nginx, or pod may contain just PHP, for example. This is a basic wrapper around Docker containers. It has reference to the image to run, for example, PHP image and Nginx image, Docker image, obviously. It has container configurations like environment variables, or like something else that you pass to container, like command to start your container with. It describes storage, like it's called volumes. For example, if you're talking about Drupal, it's like it can describe what storage to mount to sites default files folder. Pod is a thing that is expected to be stateless. I said that Kubernetes is the tool to make your Docker containers reliable, and this reliability mainly achieves by deploying containers to different nodes, so to different servers. Like when one server goes down, Kubernetes still keeps running your application through other nodes, and therefore we're achieving this stability, right? So if the pods would have depend on something external, like on a file system, then it would be a problem because the file system exists only within, for example, your node, if it's not a shared, obviously, volume. But basically, pods can't depend on anything because then it would be impossible to easily roll them, deploy them, or roll back, or replicate them, like to run the clones of the same pod on absolutely different servers, nodes, and on different domain zones or availability zones. That would be a pain. And that's why pod always stateless. You might have seen actually that our CI is doing, it builds the whole application code inside of Docker images during the build process. That is exactly what makes our images stateless, because they don't depend on any code externally. The code of the application, of an application, is inside of images. And pods containers, like in this example, PHP and Nginx, they're always in the same node, in the same server. So we can't have, as a part of one pod, two containers, which will be located on different nodes, because pod is the essential, unbreakable, unchainable thing. Let me visualize this a little bit. So here's a very standard example of pod. It contains one Docker container for Nginx, another Docker container for app. And I pulled this image from the internet, and it contains Redis here as well. But actually, this is something that makes this pod not really well, it is stateless, but it doesn't make sense to have the cache inside of the same pod, because if the pods will be replicated across multiple nodes, then every time your application accesses the Redis cache, there will be like 5 or 6 different Redis cache instances across 5 or 6 different, for example, nodes. So every time your application will access the Redis, it will be absolutely new Redis. So
I think they meant 3 different pods here, like pod Nginx, pod app.
No, that's one pod suite. See, it's container. Pod is a blue thing, and Docker container is the orange thing.
I see, but it would make sense to have 3 separated pods in this example.
2. Nginx plus application makes sense to keep in one. Just keep because Nginx is just a proxy. Why would you, for networking purpose, why would you want to move Nginx to a separate instance in the network?
If there is any other application 2 and application 3.
We're gonna get to this. It depends on how you're right in terms of it depends on how you run your application. If in your case, for example, Nginx or Traffic, this is what we use locally for managing hosts, right? In this case, it might make sense to run this as a separate pod, but Kubernetes has a solution for this. I will talk about this in like 10 minutes. Anyway, that's how the pod looks like. Obviously, pod may contain just one container, and this is totally fine. In this particular example, I would actually prefer and recommend to have Redis cache as a separate pod. So, like I said, all Docker containers within the same pods are guaranteed to be on the same server, on the same node. I think I should stop mentioning node and server always. Let's just call it node. So, for example, that's how the pods may end up on different nodes. Imagine we have 3 nodes. For example, one node may contain either one pod or as many pods as the resources of this node allow. It can be 4, 2, 1,000. It doesn't matter. As long as the resources, I mean CPU and the memory, is sufficient, Kubernetes will be placing the pods inside of those nodes. Yeah. I can quickly show you how that looks. On the real AR scenario. Can you see my command line, guys?
Yes.
Good. So if I ask Kubernetes to show me the nodes in the current cluster, it will show me.
You can probably increase font size a little bit. You just hit Command plus.
Yeah, already done. Does it make things a bit more visual?
Yeah, perfect. Thank you.
Cool. So I just said Kubernetes show me the nodes, and you can see that we have how much? 1, 2, 3, 4, 5, 6, 7, 8, 9 nodes in the cluster. This is one node, this is second node, and so on. If you're familiar a little bit with the AWS and EC2, this is a service called EC2. And we go to running instances. We will see that these are the instances. These are the nodes. You can see that there is one master node, and there are like 8 just nodes. If you look at their name, DNS, like IP 10.77.4.26, and you can find this here. This is the node. And if you talk about pods, I can show you, for example, pods for, let's say, system cheat staging. If this is available. I have dropped this. So we can see that, right? This is a list of, for example, this is a Drupal pod, which consists of 2 containers. One container is for PHP and one is for Nginx. And here is Node.js container pod, which consists of only 1 container for Node.js. I can do it even like that, which will show me on which node every pod is running. Is it clear so far?
Yes.
That's good. That's good. Let's go further then. The next concept, replica set. Basically, this thing ensures that a specified number of pods are running at any given time. Like I said, you can say that I want to run 3 clones of a pod or of my application on different nodes. Replica set is the thing that is doing this. And let's see what it does. Imagine I have a replica set which describes my pod. Pod, let's talk about the pod as like 2 containers, Nginx plus PHP. Okay, that's a simple backend application. Nginx plus PHP. So I want to deploy this to production, and I want to say that, hey, I want actually to run 3 replicas of this pod across different nodes. Okay, there you go. You have 3 replicas, A, B, C. What happens when one pod goes down? It's not available. Then Kubernetes realizes, hey, actually, there are 3 replicas, so I need to recover it. So it deployed a clone of a pod to maybe the same node, maybe different node. You never know. But basically, it makes sure that the desired amount of replicas is always in place. That's it in terms of the replica set. Deployment. This is not the deployment that you usually know. It's not the deployment which, like, I'm doing the application deployment to production. No, it's a different thing. It's yet another building block of Kubernetes, which is actually the building block which is used to change the current state to the desired. So for example, if I will deploy a pod, just a pod to Kubernetes, and it will die, Kubernetes will go like, I don't know, do you want me to recover it? No, I will do nothing. So by default, Kubernetes will not restore your pods, because pods don't have configuration of like when to recover them, when not. Deployment doesn't. And same goes for replica set. If, for example, you will want to say that instead of 2 replicas, now I need 3 replicas. If you would not use deployment to describe this, but just use replica sets here, it will tell you, well, actually, you need to do this manually. If you just deploy to Kubernetes a new replica set with 3 replicas, remove the old replica set with 2 replicas. But deployment is actually the way to describe the desired state of the pods, of the replica sets. And if you change the deployment config and say, like, I want this pod to always restart when failure. I want this pod to have 3 replicas. Deployment will go and tell Kubernetes, hey, we need to increase the amount of replicas to 3, and Kubernetes will automatically change your replica set to 3, and it will automatically spin up the pod when it fails. So the deployment is what tells Kubernetes to do things. Here's a brief example. Here's a deployment which describes replica set. I want 3 replicas, and it describes our pod with application. That's how it looks like normally. It spins up a replica set, 3 replicas, exactly what's described in the deployment. But when you want to, for example, change the amount of replicas to 2, deployment will go and tell Kubernetes, hey, we need a new replica set, a different amount of replicas, please do this. When it spins up, it drops the previous replica set. So deployment basically is a simple wrapper around replica sets and the pods, which actually tell Kubernetes what is the desired state of these pods and replica sets. Does it make sense? Or do you have any questions so far? Anyone?
No questions.
I have the impression that there is only Sergey on the line. Do we have anybody else?
Yeah, I'm here. I'm just listening to everything. Silence is golden, right?
Well, yes and no. I don't know. Silence might mean that nobody gets a thing. Anyway, let's go ahead. Services. The simple way to describe services, I think, which is more or less clear, is that service is a proxy way to access pods. Let me give you an example. Imagine we do access pods directly, and we can actually access pods directly. Every pod has unique IP address. I can show you it in my console. I've listed pods, and you can see that every pod has associated IP address to it. So theoretically, if I just expose this port to, this IP to public, I can access this pod, right? The problem happens when I want to, well, no, it's not when I want to do this, but let's think about this scenario. I do have 3 pods, replicas of the same pod. Every pod has its own IP, as you know. And imagine the client, I don't know, it can be a browser, it can be anything, it doesn't matter. Normal strategy to go around, like all pods, is just round robin. Or go to pod 1, okay, next time we make the request, it goes to pod 2, and next time we make the request pod 3, and then again to pod 1, 2, 3. That's just normal practice, how to go around a list of IP addresses, if there are many of them. What happens when one pod goes down? Basically, you still go to pod 1, it's healthy, pod 2, it's not, pod 3 is healthy. And that introduces very weird behavior, right? If I can give you another example, well, not another maybe, but just think about this from this perspective. You open a website, it works. You refresh the page, it doesn't work. You refresh the page, it works again, because now it's on pod 3. Refresh the page, pod 1, fine. Refresh the page, boom, it's crashed again. So services is sort of proxy that stands between the client and pods, and which can monitor which pods are healthy and which are not. And when one pod goes down, it just doesn't serve requests from it. It doesn't send client requests to it, and obviously doesn't send response from them. So services know that your pod number 2 went down. And then it will just work with the 2 pods. And also service is a way to expose pods to the world. When the pod is recovered, it's going to serve it again. That's basically a very brief understanding of introduction to services. So it's like lightweight proxy to pods inside of container, inside of cluster. The thing is, I don't know if that's too much information or not, but the service is the instance which does not exist. It's not a tool. Service is a way to tell Kubernetes to describe the network on the nodes. So when you create a new service, it doesn't like tell one tool to please act like an Nginx and proxy something. It actually goes around all the nodes and configures the network properly. That's it. So it doesn't exist as a tool. It just exists as something that manages network entries across the whole cluster.
Do we have something like this? Do we have name for it, or is it just service?
Name for what? Not sure I understand.
For example, for nodes, we have a correspondence EC2 instances. For pods, we understand that we have Docker images with Nginx and PHP. For services, we have something that
I don't
where
think so.
they are described in our setup.
I think maybe the closest concept to that is etc host file. Maybe that's a bad way to put it. But basically, think about services as something that puts the entries in your etc hosts file. etc/host, where you described it. Something is available under this AP. Oh, actually, you know, when you build a Docker Compose file, it automatically interlinks the container between each other, right? So from, for example, container PHP, you can access the container MySQL.
Yeah, it creates a network and assigns API address to each of containers.
Yeah, that's similar to what service does. It just creates a network and manages this network.
Are there multiple services, or is it just a concept
There are multiple services. Basically, you create a service almost to every pod. Well, you create a service to every pod which needs to be exposed to the clients. So if I want to access, for example, an Nginx, I will create a service for it. So if there is a pod, for example, with Nginx and PHP.
I see now. Okay. Now I see what does it mean. It's sort of path from outside to inside of cluster.
Right, because you don't want to give access to the pod by its IP directly, as I said, because the pod might die. You give access to the service, and then services know how many pods are there and what are their IPs. Okay, so far so good. Any more questions regarding services?
Can you show me example the services and how you create the service?
That's, to be honest, outside of the scope. I can show you. Everything is created through YAML files, normally. See? This is the server name, service name, and the IP which you should use to access the service. So if you want to access this pod, you will use this IP externally. It's a bit more complex than that, to be honest.
And this AP is always static?
That's a good question. I don't think so.
Oh, our like DNS server will manage it.
There is. The thing is that even though the services are designed to be accessed externally, there is another layer between services and the client. This is called Ingress. You can think of Ingress as it is actually a little Nginx, which does the mapping between the client and services. So Ingress knows the services. Ingress is the tool which actually, if you configure Nginx, you know the Ingress. So Ingress knows when you type the URL in the browser that this URL matches the IP of this service. So service is something to expose within a cluster inside of the cluster. Ingress is something to expose the data outside of the cluster. I think actually you can still expose the service, outside of the cluster directly if you want to make something accessible by direct IP. You can do that. And I think unless service is redeployed, the IP actually will be static. But I haven't tried this, to be honest. So this is something where I'm lacking a bit of experience. But Ingress contains the mapping between your host names, which is like domain names, let's say systemcip.com, and the service, which handles, if you, for example, go to systemcip.com, the request goes to service, to Ingress. Ingress knows that it matches Node.js service, so it will reroute the request to service, and then the service will just end up having this request in the right Node.js pod. If you go to admin.systemcip.com, then the Ingress knows that this domain maps Drupal pod, which consists of Nginx and PHP. And we go to service of this, and we'll run the proper pod.
Where does it live?
Ingress.
Yes.
I think it lives on the master node only. That's a very good question, by the way. Because you sort of deploy the pieces of Ingress configuration alongside with every application. But I think the Nginx itself likely just exists on the master. Yeah, so with every application, you just deploy the bits how to map the Ingress to your current application. But then I believe that Kubernetes aggregates again all these configurations and puts this into the master Nginx.
I think we can move on.
Okay, if you don't have more questions. And the last thing which I want to present to you in terms of the Kubernetes is a namespace. Namespace, it's known as a virtual cluster inside of a physical cluster. Physical cluster is a set of nodes. It's a physical cluster. Even though nodes could be virtual instances, but that's still called a physical cluster. Namespace is the way to separate your code by permissions, by resources, and so on. So it's like a wall between other clusters. Even though right now, like I said, we have, let me declare, we have 9 instances here. We have several virtual clusters. For example, if I can go and say, show me the deploy for production, it will show me, you can see that there are just several deployments here. If I go and say, show me the deployment for our multi-dev environment, it will show me much more. What I can do, like depending on these namespaces, like I said, I can configure different permissions. So I can say I give to developers full access to test namespace, but read only to production namespace. Or give these resources to test namespace and these resources to production namespace, and so on. So this is a way to separate applications inside of the physical cluster. Everything is namespaced in Kubernetes, by the way. So if you do, for example, Kubernetes get pods, it will give me nothing. Go give pods from production namespace, it will give me pods from the production namespace. Just be aware. I think there's another one. It's called job. It's a way to perform a certain task in Kubernetes. It does something, then exits after a successful completion or after a given period of time. A good example, if I will show you some jobs, get jobs for system seed master. A good example of jobs is when we deploy a new application, like a new release of the application, multi-dev environment, it starts 2 jobs, database import and files import. These are 2 different jobs, but this is a good example of job. Do something and die. Another example is database backup. Make the backup and die. Cron job. Well, it doesn't explicitly say that it's a cron job, but I just know this already. This is a cron job also. The difference between job and cron job, I think, is clear. Cron job just scheduled on a regular basis automatically. And the database backup is a cron job. This is a cron job. And these are database import and files import jobs, which are invoked manually when on demand, when we need to create a new instance, for example. There are a few more concepts in Kubernetes, but they are is it leader or they're just supplementary? For example, something to store configs or to store secrets and so on. I think we just went through basic understanding of Kubernetes so far. Do you have questions before we go to KOPS?
No.
Good. In terms of KOPS, I'm going to just show you one video, and that's it. You will get the idea of KOPS. KOPS stands for Kubernetes Operations. And I said that Kubernetes is something to manage the cluster of many nodes, but there's a very simple way to create this cluster. You don't need to configure it somehow manually. KOPS is a tool which just deploys Kubernetes. Well, deploys Kubernetes. Maybe this is the wrong way to put this, but imagine you have nothing on as your infrastructure, having nothing. You run KOPS, and it makes something happen. So what can you see it, guys? What it is doing? Basically,
Yes.
it defines the name of the cluster, run KOPS create, It says like it will create a cluster with the 3 nodes, with this network, blah, blah, blah. You say, okay, happy with that. Kubernetes, like, apply changes to my cluster. And after a little while, it creates new instances. You can think about in Kubernetes, it creates EC2 instances for master node, for worker nodes, does something, and done. And just you say, yeah, that's irrelevant. Kubernetes get nodes. That's what I did. There you go. You have 1 master node and 2 worker nodes created. That's it. You have Kubernetes cluster.
I thought that it uses configuration files.
Yeah, but this is the details. So we can do everything through configuration files. Of course, like you can configure what's the network, how many nodes, what are the instances. You can do everything through configuration YAML files. That's true. But just I did want to give you an understanding of what KOPS is. That's for quick deployment of a quick creation of Kubernetes cluster and autoscaling. That's it, what I wanted to show you about KOPS. That's really it. And the last thing which you need to know, called Helm. This is known as a package manager for Kubernetes. And let me show you the basic concepts of Helm. It's very simple, really. When you know it, it just has 2 things, at least, which I know. It's called charts and releases. Chart is a collection of Kubernetes building blocks like pods, deployment, services in one thing, and it has templating language. When I was talking about the building blocks of Kubernetes, you might have noticed that there are quite a few, like deployment, services, pods, and of course, a replication needs normally not just one of them. So you need somehow to manage this zoo of building blocks. And chart is just a way to have like several YAML files together. Like they may describe a few deployments, a few services, a few Ingress configurations, and that's called a chart. Like the organism, the group of these YAML files which describe Kubernetes configuration. And the good thing is that they support template language. So we can say that the name, you can dynamically insert, let's say, database host name to say that I want to host this database in the production cluster, or I want to host this database in the dev cluster, but you're using the same chart. The only thing that changes is the variable for database host. That's it, what the chart is in the nutshell. And when you deploy the chart, like I said, if you want to have one chart, one application deployed to Kubernetes with the production database storage and another one with the development database storage, you say that these are 2 different releases. And that's where we get the release concept. It's a name of the deployed chart with a certain configuration. When I deploy an application with the production host for the database, I give it a name, let's say system seed production. That's it. That's the name of my release. I've just made a release to Kubernetes. I've released the configs to Kubernetes. That's what the release is. When I want to use the same chart for releasing development application, I use the development database host name and I give it name system seed stage. That's a staging release. I just released a stage application. to Kubernetes from using the same chart. Charts are reusable. There's a like with npm or Composer, there is publicly available and downloadable charts. So, for example, if I want to connect my Kubernetes cluster to New Relic, I don't have to write deployment services and all this stuff myself. I can just go to Helm, what is it called? The package manager website, find the New Relic chart, and just download it and deploy to and release to my Kubernetes. That's it. I can create my own chart and share with somebody. I can create a chart for Drupal and share it with the open source community, and somebody else will be able to download it and use it. And by saying use it, I mean deploy it to his own Kubernetes cluster. That's what the chart is. Let me show you Helm stuff. So right now, what I'm going to do, I'm going to show you all, excuse me, all releases we have in the cluster. We do have quite many, but you can see the names of these releases, right? That looks familiar to you. And every release contains deployments, pods, services, and so on for this environment. I can delete it, I can recreate it, I can deploy it once again, but that's a release. You can also see the namespaces they belong to, test, prod. There are a few other like system Kubernetes related namespaces. But these are our custom, like prod and test. This is something that we have created for managing our applications. And you can see everywhere the chart name is the same. This is the chart which we created ourselves to deploy our headless Drupal applications with Node.js. That's it, guys. I don't have anything more to demo to you, unless you have some questions.
Thanks, Ev.
Stop sharing. Now you see my face.
Even nicer than Brad Pitt.
Ah, hi, Saif.
Yes, I was noting the whole presentation, so I think she now can go and deploy something.
That's my plan.
Yeah. Friday is the best day for deployments, by the way.
So I believe.
Friday evening is.
Friday evening of a bank holiday in Ireland.
Yeah.
Thank you, Ev. That was very interesting.
Yeah, very welcome, very welcome. Do you have any questions from your end? I know that was very technical information, and sorry, it's expected to be technical because yeah, but at the same time, you might have learned something that might be of your interest.
Absolutely. Certainly, my level of understanding will be much more high level than the rest of you. But it was very useful for me even to get a sense of the steps and the components involved in Kubernetes and deploying site on AWS. So thank you for that.
Yeah, we're welcome. Guys, do you have any questions regarding technical details or anything?
No, I think I have a question. If I, for example, imagine I created several pods, and one pod it's Drupal with Jinx. Second pod it is storage. Yes, it can be.
It's not it's a separate pod. It's just part of the Drupal plus Nginx pod. You configure the storage.
Okay. For example, I want to download file to my pod, and then I want to copy my pod. My new pod will we have my files?
It depends on how you configure the structure. But basically, you can give a persistent volume to your pod, and this volume is stored outside of Kubernetes cluster. Actually, if you talk about AWS, there is a separate file system. It's called EFS. You might have heard in NFS for Windows, for example, but this EFS, this is a elastic file system for AWS, so it makes the storage of your file in a completely different place outside of your cluster. So it doesn't matter on which node your pod is located. It will have the access to the same volume inside of EFS file system. So it's outside of the cluster. So the answer is yes, if you configure it properly, obviously.
I see. My pod will be now passed to files.
Yes.
That's all.
Yes.
Yeah. And second question, you have several charts. Name of charts the same for many charts. Code will be executed from one place, or
if I understand your question, sorry, you want to finish, or I can answer this before you complete your question. I'm assuming that you want to ask where the code of the application will be executed.
Yeah, it will be one place because it's the same charts or not.
No.
For each pods and each charts, we will create separate repository with own files.
Pods or charts have nothing to do with the repositories. Chart is as a set of YAML files, a set of Kubernetes instances. You just throw it into Kubernetes. For example, you can say that our systemc.com application contains one replica. And then what Kubernetes will do, it will create a pod in Kubernetes, will make it accessible to users, like to client. I can go and access the systemc.com website, and the code will be executed in one place on this particular pod because the code application is inside of this pod. But if you say that I want to, this is a very important website and I want to make a replica of it, like I want to spread this code across 5 different servers, then there will be 5 pods containing the same application, and then the code will be executed everywhere. I mean, the first request can go to node number 1 and they execute it there. The second request goes to node number 4 and execute the code there.
I see. It's another pods and another files.
Yes. Well, yes and no. It's certainly a new pod. It's a clone of the another pod, and that's why the pods are stateless. Because the node 1 can go down. We don't care really. We have still 3 or like 4 nodes remaining, and Kubernetes knows, like I said, it's a desired state management. So it knows that I want to have 5 replicas of the pod, but it has 4. So if there are enough resources, it will just deploy the pod to a new node. If there are not enough nodes, it will spin up a new node and put the 5th pod there. So with this, we can go really crazy in terms of failover, and we can say that we can configure on the Kubernetes level to say that please do store, I want 5 replicas, 2 of them store within this availability zone, 2 of them like in different region, and 2 of them in like 3rd availability zone. So you pretty much spread your application across the world. And even if a certain AWS, I would say, availability zone goes down, which happens almost never, but it still happens. Maybe once a few years it happens. It's fine. Kubernetes will just will go to reroute requests to other availability zones or to other regions. It can make your system really absolutely like 100% stable.
Thanks.
Yeah, we're very welcome. Any other questions, guys?
No.
Okay, if no more questions, then I will hit stop on recording.